Hello, my name is Yusuf Mısırlıoğlu. I'm in Industrial Engineering Department, and in this semester I'm taking Physics 102. In this experiment, I will examine the factors that affect the capacitance of capacitors, which are devices that store electrical energy. One of these factors is the distance between the parallel plates, while another is the dielectric constant of the material placed between them. The objective of this experiment is to examine how the distance between plates of a parallel plate, capacitor, and dielectric materials that are put between plates affect capacitance of capacitor. This experiment demonstrates essential principles of electrostatics and illustrates how changing physical parameters influences the energy storing ability of capacitors. Capacitance of capacitor has relation with the factors distance between plates, area of plates, and the epsilon, which is permittivity of free space. To find the relation, there are several key physics concepts that needs to be used, namely electric fields, Gauss law, permittivity, electrical potential. At last, this equation occurs, which is capacitance equals epsilon times area over distance. This equation is valid when there is an air between plates. However, when the electric material is placed between the plates of a capacitor, it becomes polarized due to the charged molecules within the material. Therefore, the capacitance increased by a factor called the dielectric constant, symbolized as kappa, as you can see in the screen, and the last equation becomes capacitance equals kappa times epsilon times area over distance. Therefore, for these experiments, there are some required equipments. Two plates that are covered with aluminum folio, multimeter to measure the capacitance, connecting wires, sticky tape, wood as a dielectric material, ruler to measure the distance, paper for the dielectric material, and boxes for space adjustments. In the first part, two plates were taken and measured their areas. In my case, it was 315 centimeters squared, and plates are placed parallel to each other at distances of 10, 6, 3, and 1.8 centimeter using a meter ruler. After that, multimeter was set to the capacitance mode and connected the capacitor to the multimeter using connecting wires. It is reported for every distance. Finally, plot of capacitance versus 1 over d was prepared. It is seen that capacitance directly proportional to the reciprocal of the separation. In the second part, as before, the place area stays same, which is constant value 315 centimeters squared, and the distance between the plates were set to 1.8 centimeter, which is constant variable as well. The values were taken from part A, air, as the reference measurement. In addition, the dielectric constant of each material, which are 1, 2.5, 2.8, and the corresponding capacitance when placed between the plates were recorded in the table with the help of multimeter. As you can see, paper's thickness is 1.8 cm. Finally, a plot of this capacitance versus dielectric constant was prepared. This plot clearly demonstrates direct proportionality between kappa and capacitance.